Chapter 9, review number 7. It says graph the given velocity in feet per second function with respect to time and use the graph to answer the questions below. So we're graphing a piecewise defined function, and you'll notice that these are all just going to be horizontal lines over, so let's write that, horizontal lines over these intervals. Those will be the x-axis intervals. Okay, so as x is going from 0 to 5, I should have a horizontal line at 6. Okay, horizontal line at 6. From 5 to 7, horizontal line at 2. And from 7 to 10, horizontal line at -1. Okay, what does the area under the curve represent? Well, we have talked about that quite a bit. And so you should know that the area under the curve represents the distance traveled in seconds. And for this particular graph, we're going up to 10 seconds. So it's going to be the distance, ANCE, the distance traveled in 10 seconds. Okay. What is the value of the area under the curve from 0 to 10 seconds? Okay, well, let me scoot my paper up here a little bit. So what they're asking us for is if I evaluate each section, that is going to end up being the area under the entire curve. So in other words, let's go back to the graph for a moment. If I look at this piece plus this piece, and then we're going to have to subtract this piece, what will that value be? Okay, so going back to the idea of for 5 seconds, we are traveling, we have a horizontal line at 6, plus for 2 seconds, from 5 to 7, we have a horizontal line at 2, and plus at -1, we have that horizontal line for 3 units from 7 to 10. So we're going to have 30 plus 4 minus 3, which is 31 feet. And the last part is to sketch the position graph that represents this scenario. Okay, so let's label our x and y axis. We need to get up to 10 on the x-axis, and we need to get at least more than 31. So 2, 3, 4, 5. I do not like that at all. Let's try that again. 5, 6, 7, 8, 9, 10. Okay, so 5, 10. We're going to have to extend this line. So how are we doing? 22, 23, 24, 25, 26, 27, 28, 29, 30. I know we're going to have to be a little bit above 30, but we'll figure it out. Okay, probably would have been better to count by 5s, but I was a little too far into that to change my mind. So, all right, so for the first part, we're given a horizontal line we drew a horizontal line at 6 for 5 seconds, which means for 1 second, my slope is 6 over 1. And then I'm going to do that again, 6 over 1, 6 over 1, 6 over 1, 5 times, because my time interval is from 0 to 5, which is 5 seconds. So that means that if I'm going at 6, for 5 seconds, I'm going 6 over 1. I'm really going to go 30 over 5. Up 30 over 5. So I know that at the point 530, I'm going to have my first slope line. Okay. And then we go, if you're looking at the next piece, for 2 seconds, we have a horizontal line at 2, which means for 2 seconds, we've got a horizontal line at 2. Okay, and so that is going to be up 4 over 2. So at 7. And then finally, we have our last horizontal line at -1. And so that is happening for, what do we say, 3 seconds. So at 3 seconds, we're at -1. And we're doing that each second 3 times, is how you can think of that. Okay, so it's going to be a slope of -1. Okay, so my slope for this first line should be 6. My slope for that second line should be 2. And the slope for the third line is -1. All right, if you have questions, please come to Zoom and ask.